Hello there, and welcome to the Cozy Curiosity channel. I'm so glad you found your way here tonight. Maybe you've had a long day, or maybe you just like falling asleep to gentle explorations of the world we call home. Either way, you're in the right place. Tonight, we're staying close to home. We're exploring Earth itself, this remarkable blue sphere spinning through space, covered in oceans and forests, deserts and ice, cities and wilderness. It's a planet alive with motion, mystery and quiet wonders that most of us never pause to consider. We'll drift through 100 fascinating facts about our home. Some will surprise you. Others will remind you of just how extraordinary the ordinary can be. And all of them will invite you to see Earth not as a static stage, but as a living, breathing, evolving world. If these calm explorations help you rest, feel free to like and subscribe. It helps others find their way here too, one sleepy soul at a time. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. But for now, just breathe. Let your body settle. Let your thoughts soften like evening light. And let's begin this gentle journey across the only home we've ever known. Earth is not a perfect sphere. When you picture Earth, you might imagine a perfect ball floating in space. But our planet is actually an oblate spheroid, slightly flattened at the poles and bulging at the equator. This happens because Earth rotates, and that spinning motion creates centrifugal force, pushing the equator outward. The difference isn't enormous, but it's real. The diameter at the equator is about 43 kilometers wider than from pole to pole. So Earth is more like a gently squashed orange than a marble. This subtle shape affects everything from gravity to satellite orbits. It's a quiet reminder that even the planet beneath our feet is in constant motion, shaped by forces we rarely notice. A day on Earth is getting longer. Time, it turns out, is not quite as fixed as we think. Each day on Earth is slowly, imperceptibly getting longer. About 1.7 milliseconds per century. This happens because the moon's gravity creates tidal friction, which gradually slows Earth's rotation. Billions of years ago, a day was much shorter, perhaps only 6 hours long. And in the distant future, days will stretch even longer still. The change is so gradual that no human lifetime will notice it. But over deep time, it adds up. The Earth and Moon are locked in a slow dance, tugging at each other across the void. And with every orbit, every tide, the rhythm of our days shifts just a little. Time itself breathes with the planet. Earth's core is as hot as the surface of the sun beneath your feet. Thousands of miles down, the center of the Earth burns with astonishing heat. The inner core, a solid sphere of iron and nickel, reaches temperatures of about 5,400 degrees Celsius. That's roughly the same as the surface of the sun. This intense heat comes from the residual energy of Earth's formation, combined with the decay of radioactive elements deep inside the planet. The pressure at the core is so immense that despite the heat, the iron remains solid. Above it, the outer core is liquid, and its churning motion generates Earth's magnetic field. That invisible shield protects us from solar radiation and makes compasses work. So in a way, the same fire that burns at the heart of the planet also wraps it in a gentle, protective embrace. The Amazon rainforest produces 20% of the world's oxygen. The Amazon is often called the lungs of the Earth, and for good reason. This vast expanse of green, stretching across South America, plays a crucial role in regulating the planet's atmosphere. Through photosynthesis, the trees absorb carbon dioxide and release oxygen. While the exact percentage fluctuates, scientists estimate the Amazon contributes about 20% of the oxygen we breathe. But it also does something else equally important. It stores carbon. The forest holds billions of tons of carbon in its trees, soil, and vegetation. When forests are cleared or burned, that carbon is released, accelerating climate change. The Amazon isn't just a place. It's a living system, breathing in rhythm with the planet, shaping the air we all share. Earth's magnetic field has flipped many times. The invisible magnetic field that surrounds Earth isn't fixed. Throughout geological history, the north and south magnetic poles have switched places, sometimes flipping completely. These reversals have happened hundreds of times over millions of years, though not on any regular schedule. The last major flip occurred about 780,000 years ago. During a reversal, the magnetic field weakens and becomes chaotic, sometimes splitting into multiple poles before settling into a new configuration. While this sounds dramatic, life has survived every reversal so far. Scientists monitor the field carefully as it's currently weakening and shifting, though a full flip could still be thousands of years away. It's a reminder that even the forces we think of as constant are, on geological timescales, in flux. Most of Earth's freshwater is locked in ice. When we think of freshwater, we imagine rivers, lakes, and rain. But the vast majority of Earth's freshwater, about 68%, is frozen. It's locked away in glaciers, ice caps, and the vast ice sheets of Antarctica and Greenland. Another 30% is underground in aquifers, leaving less than 1% of the planet's freshwater easily accessible in rivers, lakes, and swamps. This fragile balance means that freshwater, though renewable, is also remarkably scarce. As glaciers melt and climates shift, this frozen reserve is changing, altering the availability of water for billions of people. The ice is not just frozen water. It's a reservoir, a record, and a safeguard, and it's slowly, quietly disappearing. Lightning strikes Earth about 100 times every second. Somewhere on Earth right now, lightning is striking. About 8 million times a day, or roughly 100 flashes every second, lightning connects sky and ground in brilliant, violent bursts. Most of these strikes happen over tropical regions, where warm, moist air fuels thunderstorms. Each bolt can reach temperatures 5 times hotter than the surface of the sun, heating the air so rapidly it explodes outward, creating thunder. Lightning is essential to the planet's nitrogen cycle, converting atmospheric nitrogen into forms plants can use. It's a reminder that even in stillness, Earth is alive with energy. Storms are brewing, currents are flowing, and the atmosphere crackles with invisible power. The deepest point on Earth could swallow Mount Everest, the Mariana Trench, in the western Pacific Ocean, plunges nearly 11 kilometers beneath the surface. If you placed Mount Everest, the tallest mountain on land, at the bottom of the trench, its peak would still be more than a kilometer underwater. The pressure at this depth is crushing, over 1,000 times the atmospheric pressure at sea level. Yet life exists even here. Strange, translucent creatures drift through the darkness, adapted to conditions that would destroy most organisms. The trench is a reminder that the ocean holds mysteries as profound as space. We've sent more people to the moon than to the deepest parts of the sea. And in that silent abyss, the Earth keeps secrets we've only begun to touch. Earth's atmosphere extends far beyond what we see. When you look up at the sky, the atmosphere seems close. a thin veil above the clouds. But Earth's atmosphere actually extends much farther than most people realize. The outermost layer, the exosphere, reaches up to 10,000 kilometers above the surface, gradually fading into the vacuum of space. Most of the mass is concentrated in the lower layers, the troposphere and stratosphere, where weather happens and planes fly. But even at the edge, faint traces of atmosphere linger, interacting with solar winds and cosmic radiation. Satellites orbit within this extended envelope, and auroras dance where atmosphere meets space. The sky is not a ceiling, it's a gradient, a slow transition from air to emptiness, where Earth's breath dissolves into the stars. There are more trees on Earth than stars in the Milky Way. It's hard to imagine, but Earth is home to an estimated 3 trillion trees. That's more than the roughly 100 to 400 billion stars in our galaxy. These trees span every continent except Antarctica, from towering redwoods to tiny shrubs. They clean the air, stabilize soil, provide habitat, and store carbon. Yet despite this vast number, we're losing trees faster than they can regrow. Deforestation, fire, and development have reduced global tree cover significantly. Still, the sheer abundance is a quiet marvel. Beneath every forest canopy, roots intertwine, leaves turn sunlight into energy, and life hums in countless forms. The Earth is not barren. It is crowded with green, breathing life in every corner. The Pacific Ocean is wider than the Moon's orbit around Earth. The Pacific Ocean is vast beyond comprehension, stretching more than 19,000 kilometers at its widest point. It covers nearly a third of the planet's surface. To put that in perspective, the Moon orbits Earth at an average distance of about 384,000 kilometers, but its orbital path is much shorter than the Pacific's sheer width. This ocean holds more than half of the world's free water and influences global weather patterns, ocean currents, and climates across multiple continents. Standing on its shore, you could look out and know that the water continues for thousands of miles in every direction. It's a reminder of how much of Earth is still wild, still unexplored, still untouched by human hands. Earth's water is older than the sun. The water you drink, the rain that falls, the oceans that cover the planet, all of it is older than the sun itself. Scientists believe much of Earth's water came from icy comets and asteroids that bombarded the young planet billions of years ago. But the hydrogen and oxygen that make up water were formed even earlier, in the clouds of gas and dust that existed before our solar system took shape. This means the same molecules that now flow through rivers and fill your glass once drifted through the cold void of space, waiting to become part of a world. Water is not just essential, it's ancient. A traveler from the dawn of time, still moving, still shaping the Earth. The Earth's surface is constantly being recycled. The ground beneath your feet feels solid, permanent, but Earth's crust is in constant motion, slowly recycling itself through a process called plate tectonics. Old oceanic crust sinks back into the mantle at subduction zones, where it melts and is eventually returned to the surface through volcanic activity. This cycle takes millions of years, but it means that the seafloor is constantly being renewed. The oldest oceanic crust is only about 200 million years old, while some continental rocks are over 4 billion years old. In this way, Earth is a living system, endlessly remaking itself. What was once mountain becomes ocean floor. What was once molten becomes stone. Nothing on Earth stays still for long. Earthworms aerate more soil than all human farming. beneath the surface, an unseen workforce labors endlessly. Earthworms tunnel through the soil, digesting organic matter and leaving behind nutrient-rich castings. In doing so, they aerate the ground, allowing air and water to reach plant roots. It's estimated that earthworms turn over more soil each year than all of humanity's plows, tillers, and machines combined. In healthy soil, there can be millions of worms per acre, quietly shaping the foundation of ecosystems. Without them, soil would compact, nutrients would deplete, and plant life would struggle. These small, eyeless creatures are engineers of the earth, working in darkness, asking for nothing and giving everything to the soil that sustains us all. The longest mountain range on Earth is underwater. The mid-ocean ridge system stretches for more than 65,000 kilometers, making it the longest mountain range on the planet. It winds through every ocean, forming a continuous underwater chain of volcanic peaks and ridges. This is where tectonic plates pull apart, a new oceanic crust is born. As magma rises from the mantle and cools, most of this range lies hidden beneath miles of water, unseen and largely unexplored. Yet it plays a crucial role in shaping the ocean floor and influencing marine life. Along its length, hydrothermal vents spew superheated water, supporting ecosystems that thrive without sunlight. The mountains we see on land are just the tip of Earth's geological grandeur. The real peaks lie beneath the waves. Earth's continents are still drifting. The continents you see on a map today are not where they've always been, and they won't stay where they are. Driven by the slow churning of the mantle below, Earth's tectonic plates drift at about the same rate your fingernails grow, a few centimeters per year. Over millions of years, this adds up. Continents collide, split apart, and drift across the globe. Pangaea, the supercontinent that existed 300 million years ago, has long since broken into the continents we know today. And in the distant future, they may come together again, forming a new supercontinent. The ground beneath you is moving, silently, steadily, carrying you along on a journey that began long before humanity and will continue long after. Antarctica holds 70% of Earth's fresh water. Antarctica is a frozen desert, the driest continent on Earth. Yet it holds an astonishing amount of water. About 70% of the planet's freshwater is locked in its ice sheets, which can be up to 4 kilometers thick in some places. If all of Antarctica's ice were to melt, global sea levels would rise by about 60 meters, reshaping coastlines and submerging entire cities. But for now, the ice remains, a vast frozen reservoir that regulates global climate, reflects sunlight, and preserves ancient air bubbles from hundreds of thousands of years ago. Antarctica is not just a continent, it's an archive, a climate regulator, and a reminder of how much of Earth's water is held in suspension, waiting. The Sahara Desert was once lush and green, about 6,000 to 10,000 years ago. The Sahara wasn't a desert at all. It was a landscape of lakes, rivers and grasslands, home to hippos, crocodiles, and early human communities. Ancient rock art found in the region depicts animals and scenes that seem impossible in today's arid expanse. This transformation happened due to shifts in Earth's orbit, which altered monsoon patterns and gradually dried the region. The Sahara has cycled between wet and dry phases multiple times over the past few 100,000 years. It's a reminder that even the most extreme landscapes are not permanent. What is desert today may one day bloom again, and what is green may someday fade to sand. Earthquakes happen thousands of times every day. The Earth is always trembling. Most earthquakes are too small to feel, detected only by sensitive instruments. But thousands occur daily, as tectonic plates shift, grind, and release built-up stress. These movements are part of the planet's ongoing geological activity, the same forces that build mountains and reshape continents. Occasionally, the stress releases violently, creating quakes powerful enough to level cities. But even the smallest tremor is a reminder that Earth is not a static rock. It's a dynamic, restless sphere, constantly adjusting, settling, and moving. Beneath the calm surface, forces of unimaginable power are at work, shaping the world with every shudder and shift. The Great Barrier Reef is the largest living structure on Earth, stretching over 2,300 kilometers along the coast of Australia. The Great Barrier Reef is so vast it can be seen from space. It's not a single reef, but a complex system of thousands of individual reefs and islands, all built by tiny coral polyps over thousands of years. These organisms secrete calcium carbonate, forming the hard skeletons that become the foundation of the reef. The reef supports an astonishing diversity of life, from fish and turtles to sharks and rays. Yet it's also fragile. Rising ocean temperatures and acidification are causing widespread coral bleaching, threatening this ancient structure. The reef is a testament to life's ability to create beauty on a grand scale, and a warning of how easily it can be undone. Earth's magnetic field protects us from solar storms. The sun constantly sends out streams of charged particles, known as the solar wind. Without Earth's magnetic field, these particles would strip away the atmosphere and bombard the surface with radiation. But the magnetic field, generated by the churning molten iron in the outer core, acts as an invisible shield. It deflects most of the solar wind, channeling some particles toward the poles, where they collide with the atmosphere and create the auroras. These shimmering lights, green, pink, and violet, are the visible reminder of an invisible battle happening high above. The magnetic field doesn't just make compasses point north, it makes life on Earth possible. A single volcano can change the global climate. When a volcano erupts with enough force, it can inject massive amounts of ash, sulfur dioxide, and other particles into the stratosphere. These particles reflect sunlight back into space, cooling the planet's surface. In 1815, Mount Tambora in Indonesia erupted so violently that it led to the year without a summer in 1816, causing crop failures and famine across the northern hemisphere. More recently, the 1991 eruption of Mount Pinatubo in the Philippines cooled global temperatures by about 0.5 degrees Celsius for over a year. Volcanoes are reminders of the planet's raw power, capable of reshaping landscapes, altering climate, and affecting millions of lives with a single explosive breath. The oldest rocks on Earth are over 4 billion years old. In the remote reaches of Canada, scientists have found rocks that date back more than 4 billion years, nearly to the time when Earth itself was forming. These ancient stones are windows into a world that no longer exists, a planet of molten surfaces, violent impacts, and an atmosphere devoid of oxygen. Studying these rocks helps scientists understand how the Earth evolved from a molten ball into a stable, life-bearing world. They carry within them the chemical signatures of ancient oceans, early continents, and the very building blocks of the planet. To hold one of these stones is to touch the deep past, a fragment of Earth's infancy, still present in the world today. Earth's rotation creates the Coriolis effect. Because Earth spins, moving objects are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This phenomenon, called the Coriolis effect, influences everything from ocean currents to weather patterns. It's why hurricanes spin counterclockwise in the north and clockwise in the south. It's why trade winds follow predictable paths. The Coriolis effect doesn't change the speed of moving air or water, but it bends their direction, creating the swirling patterns we see in storms and currents. It's a subtle reminder that we live on a rotating sphere, and that rotation shapes the motion of everything on its surface, from winds to waves to the flight of a bird. Earth has experienced 5 major mass extinctions. Life on Earth has been nearly wiped out multiple times. The most famous extinction event occurred 66 million years ago, when an asteroid impact and volcanic activity killed the dinosaurs and about 75% of all species. But there have been 4 other mass extinctions, each resetting the course of evolution. The worst, the Permian extinction 252 million years ago, killed over 90% of marine species and 70% of land species. Yet life persisted. From these devastations came new forms, new ecosystems, and eventually, us. Each extinction is a reminder of life's fragility and resilience. The story of Earth is not one of uninterrupted progress, but of collapse and renewal, over and over again. The Earth's inner core spins at a different speed, deep inside the planet. The solid inner core rotates independently of the rest of Earth. It spins slightly faster than the outer layers, completing an extra rotation about every 1,000 years. This happens because the inner core is suspended within the liquid outer core, free to move at its own pace. Scientists discovered this by analyzing seismic waves from earthquakes, which travel through the core and reveal its motion. The inner core's spin influences the magnetic field and may play a role in its fluctuations over time. It's a strange thought. While we spin through space on Earth's surface, the very center of the planet spins at its own rhythm, a hidden heartbeat deep below. Most of Earth's oxygen comes from the ocean. We often credit forests for the air we breathe, but the truth is more surprising. About 50 to 80% of Earth's oxygen is produced by phytoplankton, microscopic organisms that drift in the ocean's sunlit surface waters. These tiny plants perform photosynthesis, just like trees, absorbing carbon dioxide and releasing oxygen. Though invisible to the naked eye, they outnumber stars in their abundance and importance. A single drop of seawater can contain thousands of these organisms, all quietly generating the oxygen that sustains life on land and sea. The ocean is not just a body of water. It's the planet's greatest lung, breathing in rhythm with every wave. The moon's gravity creates 2 high tides a day. The moon pulls on Earth's oceans, creating a bulge of water on the side closest to it. But there's also a bulge on the opposite side, caused by the inertia of the water, as Earth and Moon orbit their common center of mass. As Earth rotates, these bulges move across the planet, creating 2 high tides and 2 low tides, roughly every 24 hours. The sun also influences tides, though to a lesser extent. When the sun, moon, and Earth align, their combined pull creates especially high spring tides. When they're at right angles, the result is weaker, neap tides. The tides are a dance between celestial bodies, felt in every shoreline, every harbor, every grain of sand touched by the sea. Earth's atmosphere is 78% nitrogen. When you take a breath, you're mostly inhaling nitrogen. About 78% of the atmosphere is made of this colorless, odorless gas. Oxygen, the gas we need to survive, makes up only about 21%. The remaining 1% includes argon, carbon dioxide, water vapor, and trace gases. Nitrogen is essential for life, though not in the form we breathe. Plants need it to grow, and specialized bacteria in the soil convert atmospheric nitrogen into forms plants can use. Without this invisible majority, the balance of gases that supports life would collapse. Every breath is a reminder of the precise mixture that makes Earth livable, a delicate blend maintained by life itself. Some deserts receive less than 1 inch of rain per year. The driest place on Earth is the Atacama Desert in Chile, where some regions have never recorded rainfall in human history. These extreme deserts are shaped by geography, air currents, and rain shadows cast by mountains. Yet even in such harsh conditions, life finds a way. Microbes cling to rocks, fog-harvesting plants capture moisture from the air, and animals survive on the tiniest drops of water. Deserts are not dead. They're landscapes of endurance, where every drop of moisture is precious, and every living thing is a master of survival. In their silence and stillness, deserts remind us that life is not defined by abundance, but by adaptation. The Earth's shadow causes lunar eclipses. When the Earth passes directly between the Sun and the Moon, it casts a shadow that darkens the Moon's surface. This is a lunar eclipse, and it can only happen during a full moon. As the Moon moves through Earth's shadow, it often takes on a reddish hue, sometimes called a blood moon. This happens because Earth's atmosphere bends and scatters sunlight, filtering out blue wavelengths and allowing red light to reach the Moon. Lunar eclipses have been observed and recorded for thousands of years, inspiring myths, rituals, and scientific wonder. They're a reminder that even in the vastness of space, Earth's presence can be felt, casting its quiet shadow across the heavens. Earth's soil takes thousands of years to form. Soil isn't just dirt. It's a complex, living ecosystem that takes centuries or even millennia to develop. It forms from the slow weathering of rock, mixed with organic matter from decaying plants and animals. Microbes, fungi, worms, and countless other organisms break down material, creating the rich, fertile layers that support plant life. In some regions, it can take 500 to 1,000 years to form just 1 inch of topsoil. Yet erosion, deforestation, and poor farming practices can destroy it in a fraction of that time. Soil is not a renewable resource on human timescales. It's an inheritance from the deep past, and once lost, it may never return. The Himalayas are still rising. Every year, the Himalayas grow a few millimeters taller. This happens because the Indian tectonic plate continues to push northward into the Eurasian plate, a collision that began about 50 million years ago and created the world's tallest mountain range. The force of this slow-motion crash is so immense that it has lifted the Tibetan Plateau and continues to reshape the region. Earthquakes are frequent reminders of the ongoing tectonic activity. Mount Everest, the tallest peak, gains height with every passing year, though erosion and landslides work to wear it down. The mountains are not monuments of the past. They're still being built, rising imperceptibly, breath by breath, into the sky. Earth's oceans contain gold. Dissolved in the world's oceans is an estimated 20 million tons of gold. That's more than all the gold ever mined by humanity. But before you start panning seawater, know that the concentration is incredibly low, only about 13 billionths of a gram per litre. Extracting it would cost far more than the gold is worth. The gold enters the ocean through rivers, volcanic activity, and hydrothermal vents. and it stays dissolved, invisible, and largely inaccessible. It's a reminder that the ocean holds treasures beyond what we can see, riches that remain locked in the chemistry of saltwater, drifting unseen beneath the waves. Earth's tilt gives us seasons. The reason we have spring, summer, autumn, and winter is because Earth's axis is tilted at about 23.5 degrees relative to its orbit around the Sun. This tilt means that different parts of the planet receive varying amounts of sunlight throughout the year. When the northern hemisphere is tilted toward the Sun, it experiences summer, while the southern hemisphere has winter. 6 months later, the situation reverses. Without this tilt, there would be no seasons, just a constant climate determined by latitude. The tilt is thought to have been caused by a massive collision early in Earth's history, the same event that may have created the Moon. It's a cosmic accident that gave the planet its rhythm, its cycles, its ever-changing beauty. The Great Salt Lake is saltier than the ocean. Utah's Great Salt Lake is one of the saltiest bodies of water on Earth, with salinity levels reaching up to 27% compared to the ocean's 3.5%. This happens because the lake has no outlet. Water flows in from rivers, but it can only leave through evaporation, leaving behind dissolved salts. Over time, these salts have concentrated to extreme levels, creating an environment where only specially adapted organisms can survive. Brine shrimp thrive here, and their eggs can remain dormant for years, waiting for the right conditions. The lake is a reminder that even landlocked waters can hold extremes, small ecosystems shaped by isolation and evaporation. Earth's biodiversity is still mostly unknown. Scientists estimate there are between 8 and 10 million species on Earth, but we've only identified and described about 1.5 to 2 million. The rest remain unknown, hidden in rainforests, deep oceans, soil, and even our own bodies. Every year, thousands of new species are discovered, from tiny insects to deep-sea fish. Many will go extinct before we ever know they existed. This vast, invisible diversity is a reminder of how little we truly understand about the planet we live on. Life is everywhere, in every crack, every drop of water, every handful of soil. And most of it is still waiting to be seen. Lightning can heat the air to 30,000 degrees Celsius. When lightning strikes, it creates a channel of superheated air, reaching temperatures around 30,000 degrees Celsius, 5 times hotter than the surface of the sun. This extreme heat causes the air to expand explosively, creating the sound we call thunder. The entire process, from flash to boom, happens in a fraction of a second. Lightning is not just a visual spectacle. It's a release of energy built up in storm clouds, a connection between sky and earth that has fascinated and terrified humans for millennia. And in that brief, brilliant moment, the air itself becomes fire. The Amazon River flows backward during high tide. The Amazon is the largest river by volume in the world, discharging more water into the ocean than the next 7 largest rivers combined. But during high tide, seawater pushes back into the river's mouth, creating a phenomenon where the river's flow temporarily reverses. This tidal influence can extend hundreds of kilometers inland, mixing salt and fresh water in a dynamic, shifting boundary. The force of the tide can also create a tidal bore, a wave that surges upstream, sometimes reaching heights of several meters. It's a reminder that even the mightiest rivers are not one-way flows. They breathe with the ocean, responding to the rhythm of the tides. Earth's gravity is not uniform. gravity varies slightly across the planet's surface. This happens because Earth's mass is not evenly distributed. Mountains, ocean trenches, and differences in crust density all affect the gravitational pull. Satellites like GRACE have mapped these variations with incredible precision, revealing a lumpy, uneven gravitational field. In some places, gravity is slightly stronger. In others, it's weaker. These differences are too small to feel, but they affect everything from ocean currents to satellite orbits. It's a reminder that even something as fundamental as gravity is not constant. It shifts, bends, and changes depending on where you are. The longest cave system is over 600 kilometers long. Mammoth Cave in Kentucky is the world's longest known cave system, with more than 650 kilometers of explored passageways, and new sections are still being discovered. The cave formed over millions of years as acidic water dissolved limestone, creating vast underground chambers, rivers, and labyrinths. Some passages are wide enough to walk through. Others require crawling. The cave is home to unique species, including eyeless fish and colorless crayfish, adapted to life in total darkness. Mammoth Cave is a hidden world beneath the surface, a reminder that Earth's interior holds wonders as vast and strange as anything above ground. Earth's crust is thinnest beneath the oceans. The ground beneath your feet feels solid and deep, but Earth's crust is surprisingly thin, especially under the oceans. Oceanic crust is only about 5 to 10 kilometers thick, while continental crust can be 30 to 50 kilometers deep. This difference affects everything from volcanic activity to the formation of mountains. Where oceanic crust meets continental crust, the denser oceanic plate often sinks beneath, creating subduction zones and triggering earthquakes and volcanoes. The thin oceanic crust is also younger, constantly being recycled through tectonic processes. It's a reminder that the solid ground we depend on is just a fragile shell floating on a molten, restless interior. The world's oldest tree is over 5,000 years old. In California's White Mountains stands a bristlecone pine known as Methuselah, estimated to be more than 4,950 years old. Its exact location is kept secret to protect it. These trees grow slowly in harsh, high-altitude environments, developing dense, twisted wood that resists decay. They've witnessed the rise and fall of civilizations, climate shifts, and the slow march of centuries. Tree rings from ancient bristlecones provide a record of past climates, droughts, and environmental changes. To stand near one is to stand in the presence of deep time, a living witness to millennia of change. Earth's atmosphere was once poisonous to most life. Billions of years ago, Earth's atmosphere contained almost no oxygen. Early life thrived in an oxygen-free world, until cyanobacteria began producing oxygen through photosynthesis. This oxygen accumulated slowly, eventually triggering the Great Oxidation Event about 2.4 billion years ago. For many organisms, oxygen was toxic, and this event caused a massive die-off. But it also paved the way for more complex life, including us. The oxygen we now depend on was once a deadly poison. It's a reminder that Earth's history is full of transformations, and that even the air we breathe is the result of life reshaping the planet. The Nile River flows north. Most rivers flow south, toward the equator, but the Nile is different. It flows northward from the highlands of East Africa to the Mediterranean Sea. This happens because gravity pulls water downhill, regardless of compass direction. The Nile follows the natural slope of the land, carving a path through deserts, and sustaining civilizations for thousands of years. Ancient Egypt depended entirely on its annual floods, which deposited fertile silt along the banks. The river is a reminder that the flow of water shapes not just landscapes, but human history, culture, and survival. Glaciers hold 75% of the world's fresh water, though they cover only about 10% of Earth's land surface. Glaciers store an astonishing 3/4 of the planet's fresh water. These slow-moving rivers of ice form over centuries from compressed snow, and they sculpt valleys, carve mountains, and feed rivers as they melt. But glaciers are shrinking. Climate change is accelerating their retreat, altering water supplies for millions of people. The meltwater feeds rivers in spring and summer, providing a steady flow when it's needed most. As glaciers vanish, that flow becomes unpredictable. The ice is not just frozen water. It's a reservoir, a lifeline, and a barometer of the planet's changing climate. Earth's oceans are rising. Sea levels have risen about 20 centimeters over the past century, and the pace is accelerating. This happens for two main reasons. Thermal expansion. As ocean water warms, it expands, and the melting of glaciers and ice sheets. Even a small rise can have dramatic effects, flooding coastal cities, eroding shorelines, and displacing millions of people. Low-lying islands and coastal regions are already feeling the impact. The rise is not uniform. Currents, winds, and gravitational effects mean some areas experience more change than others. It's a slow creep, barely noticeable year to year, but unstoppable in its momentum. The Atacama Desert hasn't seen rain in decades. In some parts of Chile's Atacama Desert, weather stations have never recorded rainfall. The region is so dry because it sits in a double rain shadow, blocked by the Andes to the east and a coastal range to the west. Moisture from the ocean rarely makes it inland. Yet life persists. Microbes survive in the soil, and during rare fog events, plants bloom briefly before retreating into dormancy. The Atacama is sometimes used as a stand-in for Mars, a place where scientists test instruments designed for alien worlds. In its silence and emptiness, it shows us that even the driest corner of Earth holds lessons about survival, patience, and the limits of life itself. Earth has more than 1,500 active volcanoes scattered across the planet. More than 5,500 volcanoes are considered active, meaning they've erupted in the past 10,000 years, or show signs of unrest. Most are concentrated along tectonic plate boundaries, especially around the Pacific Ring of Fire. Some erupt frequently, like Kilauea in Hawaii, which has been erupting almost continuously since 1983. Others sleep for centuries before awakening. Volcanoes are not just destructive, they create new land, enrich soil with minerals, and release gases that have shaped Earth's atmosphere over billions of years. They're reminders that the planet is alive beneath us, breathing fire and stone, building and destroying in endless cycles. The Dead Sea is sinking. The Dead Sea, already the lowest point on Earth's land surface at about 430 meters below sea level, is sinking by about a meter per year. This happens because the sea is evaporating faster than it's being replenished. Water is diverted from the Jordan River for agriculture and drinking, leaving less to flow into the sea. As water levels drop, sinkholes appear along the shore, swallowing roads and buildings. The sea's extreme salinity, nearly 10 times that of the ocean, makes it impossible for most life to survive. Hence its name. Yet it's been a source of minerals and healing for thousands of years. Now it's disappearing, a casualty of human demand and desert heat. Earth's atmosphere leaks into space. Every second, Earth loses about 3 kilograms of hydrogen to space. This happens in the uppermost layers of the atmosphere, where lightweight gases can escape the planet's gravitational pull. Over billions of years, Earth has lost a significant amount of its original atmosphere this way. Heavier gases like nitrogen and oxygen are held more tightly, but even they slowly drift away. This atmospheric escape is one reason why planets like Mars, with weaker gravity, have such thin atmospheres today. Earth is constantly leaking, breathing out into the void. Though the loss is so gradual, we'll never notice it in a human lifetime. The longest living animal is over 500 years old. A Greenland shark pulled from the North Atlantic was estimated to be at least 512 years old, making it the longest-lived vertebrate known to science. These sharks grow incredibly slowly in the cold Arctic waters, reaching maturity only after 150 years. They move through the deep ocean in near darkness, feeding on fish and carrion, their lives spanning centuries of human history. Some alive today were born before Shakespeare wrote his plays. Their longevity is a mystery, possibly linked to their cold environment and slow metabolism. They're living fossils, silent witnesses to centuries of change above the waves. Rainforests are home to half of all species. Tropical rainforests cover less than 7% of Earth's land surface, yet they contain more than half of the world's plant and animal species. This incredible diversity exists because rainforests have stable climates, abundant rainfall, and complex vertical structures that create countless ecological niches. A single tree can host hundreds of species, from insects to birds to fungi. But rainforests are disappearing rapidly, cleared for agriculture, logging, and development. With them go species we've never identified, medicines we'll never discover, and ecosystems that have existed for millions of years. The rainforest is not just a place, it's a library of life, written in DNA, and we're burning the pages. Mountains create their own weather. When moist air rises over a mountain range, it cools and condenses, creating clouds and precipitation on the windward side. By the time the air descends on the other side, it's dry, creating what's called a rain shadow. This is why one side of a mountain can be lush and green, while the other is arid and barren. Mountains also generate winds, trap clouds, and influence temperature patterns across entire regions. They're not just obstacles to weather, they shape it, creating microclimates, fog belts, and weather systems that can extend for hundreds of kilometers. The presence of a mountain changes the sky itself. Earth's iron core is slowly solidifying. At the very center of the planet, the inner core is solid iron and nickel, but the outer core is liquid. As Earth slowly cools over billions of years, the liquid outer core crystallizes, adding to the solid inner core. This process releases heat, which helps drive the convection currents in the outer core that generate Earth's magnetic field. The inner core grows by about 1 millimeter per year, an almost imperceptible change. But over deep time, the entire core may eventually solidify, shutting down the magnetic field and leaving Earth vulnerable to solar radiation. That won't happen for billions of years, but it's a reminder that even the deepest parts of the planet are slowly, steadily changing. Deserts are expanding. Desertification, the process by which fertile land becomes desert, is accelerating due to climate change, overgrazing, and deforestation. The Sahara Desert alone has expanded by about 10% over the past century. As vegetation disappears, the soil loses its ability to retain water, and wind erosion carries away the topsoil. This creates a feedback loop where the loss of plants leads to more desert, which makes it harder for plants to return. Millions of people depend on land that's turning to dust beneath them. Deserts are natural, but their expansion is often driven by human activity. And once land turns to desert, it's extraordinarily difficult to bring it back. The longest river is debated. For years, the Nile was considered the longest river, at about 650 kilometers. But some measurements suggest the Amazon, at roughly 6,400 to 7,000 kilometers, depending on where you start counting, might be longer. The debate comes down to defining a river's source, where tributaries begin and end, and which measurements to trust. Both rivers are immense, shaping continents and sustaining millions of lives. The Nile flows through deserts, while the Amazon cuts through rainforest. One is ancient history. The other is wild abundance. Both are testaments to water's power to carve, nourish, and define the land. Earth's poles are melting asymmetrically. The Arctic is warming about twice as fast as the rest of the planet, causing rapid ice loss in Greenland and the Arctic Ocean. Antarctica is more complex. Some areas are losing ice quickly, especially in the West Antarctic ice sheet, while other parts are stable or even gaining ice in the interior. This asymmetry affects sea level rise, ocean currents, and weather patterns globally. As Arctic sea ice melts, it exposes dark ocean water, which absorbs more sunlight, accelerating warming. The poles are not just cold places at the edge of the world. They're thermostats, and their melting is changing the climate for everyone. Bioluminescence lights up the deep sea. In the lightless depths of the ocean, more than 90% of creatures produce their own light through bioluminescence. They use it to hunt, communicate, confuse predators, and attract mates. The chemicals involved vary, but the result is the same: a cold, eerie glow in the darkness. Jellyfish pulse with blue light. Anglerfish dangle luminous lures. Entire schools of fish flash in coordinated patterns. This hidden light show happens every night in the deep ocean, unseen by human eyes. A reminder that the sea holds wonders we can barely imagine. Life finds ways to shine, even in the deepest darkness. Earth's largest desert is Antarctica. When we think of deserts, we imagine sand and heat. But a desert is defined by lack of precipitation, not temperature. Antarctica receives almost no rain or snow in its interior, making it the largest desert on Earth by area. It's a frozen desert, where the little snow that falls never melts, accumulating over millions of years into ice sheets kilometers thick. The air is so dry that some valleys haven't seen precipitation in 2 million years. Life is scarce, limited to hardy microbes and lichens clinging to rocks. Antarctica is an alien landscape, a desert of ice and silence at the bottom of the world. Coral reefs are built by tiny animals. Coral may look like colorful rocks or plants, but they're actually colonies of tiny animals called polyps. Each polyp secretes calcium carbonate, forming a hard skeleton. Over time, millions of these skeletons pile up, creating the massive structures we call reefs. Coral polyps have a symbiotic relationship with algae called zooxanthellae, which live inside them and provide energy through photosynthesis. When water becomes too warm, the coral expels the algae, turning white in a process called bleaching. Without the algae, the coral starves. Reefs are some of the most biodiverse ecosystems on Earth, built by creatures smaller than your fingernail, working together across centuries. The sun's energy takes 100,000 years to reach its surface. The light we see from the sun takes about 8 minutes to travel to Earth. But the energy that produces that light begins its journey at the sun's core, where nuclear fusion generates photons. Those photons bounce around inside the sun, absorbed and re-emitted countless times, taking a chaotic, random path. It can take 100,000 years or more for a photon to work its way from the core to the surface. Once it escapes, it races through space in minutes. The sunlight, touching your face right now, began its journey long before humans built cities, before we painted on cave walls, before we were even recognizably human. Earth's forests produce cooling effects beyond carbon storage. Forests don't just absorb carbon dioxide. They also cool the planet through evapotranspiration, the process by which water evaporates from leaves and soil. This releases moisture into the atmosphere, forming clouds and reflecting sunlight. Forests also have lower albedo, meaning they absorb more heat than bare ground or ice. But the cooling from evapotranspiration often outweighs the warming from heat absorption. In tropical regions, forests create their own rainfall, sustaining themselves through the water they release. When forests are cut down, the local climate changes, temperatures rise, and rainfall patterns shift. Trees are not just carbon sinks, they're climate regulators, shaping weather from the ground up. The Mariana Trench could fit Mount Everest with room to spare. If you placed Mount Everest, the tallest mountain on land, at the bottom of the Mariana Trench, its peak would still be more than a kilometer underwater. The trench plunges to nearly 11,000 meters below the surface, a depth so extreme that only a handful of people have ever visited it. The pressure at the bottom is over 1,000 atmospheres, enough to crush most submarines. Yet life exists even there. Strange, ghostly fish, translucent shrimp, and microbes adapted to crushing pressure and total darkness. The trench is a world unto itself, as alien as any planet, yet part of our own. Earth's rotation is slowing the moon's orbit. The moon's gravity creates tidal bulges in Earth's oceans, and as the planet rotates beneath these bulges, friction occurs. This friction gradually slows Earth's rotation, making days slightly longer over millions of years. But the process also transfers energy to the moon, pushing it farther away from Earth by about 3.8 centimeters per year. Billions of years ago, the moon was much closer, looming large in the sky and creating more dramatic tides. In the distant future, it will be farther still, a smaller, dimmer presence. The moon is drifting away, slowly, silently, a reminder that even the most constant companions eventually part. Underground rivers flow beneath deserts. In places like the Sahara, vast underground aquifers hold water that fell as rain thousands or even millions of years ago. These aquifers are like hidden rivers, flowing slowly through porous rock far below the surface. In some places, this ancient water seeps to the surface, creating oases. In others, it's tapped by wells, providing life to desert communities. But many of these aquifers are not being replenished. The water is fossil water, finite and irreplaceable. As it's pumped out, the resource dwindles, and the land above may sink. The desert hides water beneath its sands, a secret reserve slowly being drained. Earth's clouds reflect sunlight. Clouds play a crucial role in regulating Earth's temperature. They reflect about 20% of incoming solar radiation back into space, cooling the planet. But they also trap heat radiating from the surface, creating a warming effect. The balance between these two effects depends on the type, altitude, and thickness of the clouds. Low, thick clouds tend to cool. High, thin clouds tend to warm. As the climate changes, cloud patterns shift, and scientists are still working to understand how this will affect global temperatures. Clouds are not passive. They're active players in the climate system, shaping the heat balance of the entire planet. Earth's oldest fossils are 3.5 billion years old. In Western Australia, scientists have found fossils of microbes that lived 3.5 billion years ago, not long after Earth's surface cooled enough to support life. These ancient organisms were simple, single-celled, and likely lived in shallow water or near hydrothermal vents. They're among the earliest evidence of life on Earth, preserved in stone across billions of years. Studying them helps scientists understand how life began, what conditions were necessary, and what early Earth looked like. These fossils are not just rocks, they're messages from the deep past, proof that life has endured through unimaginable spans of time. The Gulf Stream carries heat across the Atlantic. The Gulf Stream is a powerful ocean current that flows from the Gulf of Mexico across the Atlantic toward Europe. It carries warm water northward, releasing heat into the atmosphere and moderating the climate of Western Europe. Without the Gulf Stream, cities like London and Paris would be much colder, more like cities at similar latitudes in Canada. The current is part of a larger system of ocean circulation, driven by temperature and salinity differences. But as climate changes, scientists worry that melting ice could disrupt this circulation, potentially altering climates across entire continents. The Gulf Stream is not just a current, it's a conveyor belt of heat, shaping weather thousands of kilometers away. Earth's tallest waterfall is underwater. The Denmark Strait Cataract, located between Greenland and Iceland, is the largest waterfall on Earth. Cold, dense water from the Nordic seas plunges over an underwater ridge, dropping more than 3,500 meters to the ocean floor below. The flow rate is immense, about 175 million cubic meters per second, over 2,000 times greater than Niagara Falls. This underwater cascade is part of the global ocean circulation system, driving currents that distribute heat and nutrients around the world. It's invisible from the surface, hidden in the depths, yet it's one of the most powerful flows of water on the planet. Permafrost holds ancient carbon. In the Arctic, permafrost, permanently frozen ground, has been locked in place for thousands of years. Trapped within it is organic matter from ancient plants and animals, containing an estimated 1,600 billion tons of carbon, twice as much as currently in the atmosphere. As temperatures rise, permafrost is thawing, and microbes are breaking down this organic matter, releasing carbon dioxide and methane. This creates a feedback loop. Warming causes thawing, which releases greenhouse gases, which causes more warming. It's a slow-motion time bomb, releasing carbon that's been frozen since the last ice age. The ground itself is becoming a source of emissions, amplifying the very warming that's causing it to thaw. Earth's driest place is in Antarctica. While the Atacama Desert is dry, the driest place on Earth is actually in Antarctica, in the McMurdo Dry Valleys. These valleys receive almost no precipitation, and what little snow falls is immediately sublimated by dry winds. Some areas haven't seen water in millions of years. The landscape is stark, barren, and eerily Mars-like, which is why NASA uses it to test equipment for space missions. Yet even here, life persists. Microbes live inside rocks, protected from the wind and cold, surviving on traces of moisture and sunlight. The dry valleys remind us that life is tenacious, clinging to existence even in the most extreme corners of the planet. The Pacific Ring of Fire hosts most earthquakes. The Ring of Fire is a horseshoe-shaped zone around the Pacific Ocean, where tectonic plates meet and collide. About 90% of the world's earthquakes and 75% of its volcanoes occur here. The ring stretches from New Zealand, up through Japan and Alaska, and down the west coasts of North and South America. This intense geological activity is the result of subduction, where oceanic plates dive beneath continental plates, triggering quakes and fueling volcanic eruptions. The Ring of Fire is a reminder of the planet's restless energy, a zone where the Earth's interior breaks through the surface with dramatic, sometimes devastating force. Earth's air is full of microbes. Every breath you take contains thousands of bacteria, fungi, and viruses floating in the air. These microbes drift on dust particles, water droplets, and air currents, traveling across continents and oceans. Some can survive high in the atmosphere, exposed to UV radiation and freezing temperatures. They play roles in cloud formation, nutrient cycling, and even disease spread. The air is not empty. It's teeming with microscopic life, an invisible ecosystem floating above us, shaping the world in ways we're only beginning to understand. We live in a cloud of life, breathing it in with every inhale. Earth's oxygen levels have fluctuated dramatically. About 300 million years ago, during the Carboniferous period, oxygen made up about 35% of the atmosphere, compared to 21% today. This higher oxygen level allowed insects and other arthropods to grow to enormous sizes. Dragonflies had wingspans of over 70 centimeters. Millipedes grew to more than 2 meters long. As oxygen levels dropped, these giants disappeared. The fluctuations in oxygen are tied to the rise and fall of plant life, volcanic activity, and the burial of organic matter. The air we breathe today is not a constant. It's the result of billions of years of life reshaping the atmosphere, a balance maintained by ecosystems and geological processes working in concert. Lakes can explode. In rare cases, volcanic lakes can accumulate large amounts of dissolved carbon dioxide in their depth. If something disturbs the water, a landslide, an earthquake, or even heavy rain, the gas can suddenly erupt from the lake in a deadly cloud. This happened at Lake Nyos in Cameroon in 1986, when a massive release of CO2 suffocated more than 1,600 people and thousands of animals in nearby villages. The gas, heavier than air, flowed down valleys like an invisible river of death. Scientists now monitor these lakes and have installed systems to slowly release the gas before it can build to dangerous levels. These lakes are beautiful, but they hold a hidden threat, a reminder that even water can be deadly. Earth's continents were once one. About 300 million years ago, all of Earth's continents were joined together in a single supercontinent called Pangaea. Surrounded by a vast ocean called Panthalassa, Pangaea eventually began to break apart due to tectonic forces. Over millions of years, the pieces drifted to their current positions, forming the continents we know today. But this is not the end of the story. The continents are still moving, and in about 200 million years, they may come together again, forming a new supercontinent. The cycle of supercontinent formation and breakup has happened multiple times in Earth's history, each time reshaping the planet geography, climate, and life. Dust from the Sahara fertilizes the Amazon. Every year, trade winds carry millions of tons of dust from the Sahara Desert across the Atlantic Ocean to South America. This dust, rich in phosphorus and other nutrients, settles in the Amazon rainforest, replenishing the soil and supporting plant growth. Without this annual dust delivery, the Amazon would be less productive, as its soils are naturally poor in nutrients, constantly leached by heavy rainfall. The Sahara and the Amazon, two vastly different ecosystems separated by an ocean, are connected by wind and dust. It's a reminder that the Earth is a system where distant parts influence each other in ways both subtle and profound. Earth's longest mountain range is hidden. We've mentioned the mid-ocean ridge before, but it's worth repeating just how vast it is. Stretching over 65,000 kilometers, this underwater mountain range is 4 times longer than the Andes, Rockies, and Himalayas combined. It runs through every ocean, a continuous chain of volcanic peaks and rift valleys. Along its length, new ocean floor is constantly being created as magma rises from the mantle. Hydrothermal vents dot the ridge, spewing superheated water and supporting ecosystems that don't depend on sunlight. The ridge is a hidden spine running through the planet's oceans, a reminder that much of Earth's grandest geology lies beneath the waves, unseen. Glaciers can move faster than you walk. While glaciers are often described as slow-moving rivers of ice, some can surge forward at surprising speeds. During a glacial surge, ice can move several meters per day, or even up to 100 meters in extreme cases. These surges happen when meltwater lubricates the base of the glacier, allowing it to slide more easily over the bedrock. The surge can last months or years before the glacier returns to its normal pace. Glaciers are not static. They flow, crack, and reshape the land beneath them, carving valleys and polishing stone. They're dynamic, powerful, and in some cases, startlingly fast. The ocean's deepest point was visited by only 4 people. The Challenger, deep, the deepest part of the Mariana Trench, has been visited by just 4 people in history. James Cameron, the filmmaker, made a solo dive in 2012. In 2019, Victor Vescovo descended in a specially designed submarine, and in 1960, Jacques Piccard and Don Walsh were the first to reach the bottom. The journey takes hours, descending through layers of increasing darkness and pressure. At the bottom, the weight of the ocean presses down with more than 1,000 times the pressure at sea level. Yet even there, life exists, a reminder that the ocean's depths are not empty voids, but ecosystems we've barely begun to explore. Earth's mantle is slowly convecting. Beneath the crust lies the mantle, a thick layer of hot, semi-solid rock. Though it seems solid, the mantle flows very slowly over millions of years, driven by heat from the core. Hot material rises, cools, and sinks, again in massive convection currents. These currents drive tectonic plate movement, causing earthquakes, volcanic eruptions, and the drifting of continents. The mantle is the engine of Earth's geology, a hidden churning that shapes the surface. It's a reminder that the ground beneath us is not as solid as it seems. Deep below, the planet is in constant motion, reshaping itself over timescales far beyond human comprehension. Raindrops are not teardrop-shaped. Despite what cartoons show us, raindrops are not shaped like teardrops falling through the air. Small raindrops are nearly spherical, held together by surface tension. As they grow larger, air resistance flattens the bottom, giving them a shape more like a hamburger bun. Very large drops become unstable, and break apart before they reach the ground. The teardrop shape is a fiction, a simplified symbol we use to represent rain. But the real thing is more complex, shaped by invisible forces as it falls. Even something as simple as a raindrop is more interesting than we imagine. Earth's soil contains more organisms than there are humans. A single handful of healthy soil contains more microorganisms than there are people on Earth. Billions of bacteria, fungi, protozoa, and nematodes live in every gram of soil, breaking down organic matter, cycling nutrients, and supporting plant growth. This invisible ecosystem is the foundation of all terrestrial life. Without it, nothing would grow. The soil is not dirt, it's a living community, as complex and diverse as any rainforest, teeming with life too small to see, but essential to everything above it. The moon is moving away from Earth. Every year, the moon drifts about 3.8 centimeters farther from Earth. This happens because the gravitational interaction between Earth and the moon transfers rotational energy from Earth to the moon's orbit. Billions of years ago, the moon was much closer, appearing enormous in the sky and creating massive tides. In the distant future, it will be smaller and dimmer, and Earth's days will be longer. Eventually, Earth and Moon will become tidally locked, each showing only one face to the other, frozen in a gravitational embrace. But that won't happen for billions of years. For now, the Moon continues its slow retreat across the void. Icebergs can be green. Most icebergs are white or blue, but occasionally green icebergs are spotted in Antarctic waters. Scientists believe these form when iron-rich seawater freezes to the underside of ice shelves, creating jade-colored ice. When chunks break off, they float as green icebergs, rare and striking against the blue sea. The iron may come from glaciers grinding against bedrock, releasing minerals into the water. These green giants are reminders that even ice, frozen and seemingly simple, can hold chemistry, color, and mystery. Nature creates wonders in the most unexpected forms. Time threes. Earth's fastest winds are in tornadoes. The strongest winds ever recorded on Earth occur inside tornadoes, where speeds can exceed 480 kilometers per hour. These violent rotating columns of air form from severe thunderstorms when conditions align perfectly. Warm, moist air collides with cool, dry air, and wind shear sets the system spinning. Tornadoes can lift cars, demolish buildings, and carve paths of destruction kilometers long, yet they're also localized and brief, often lasting only minutes. The power concentrated in a tornado is staggering, a reminder that the atmosphere, usually so gentle, can become a force of terrifying intensity. Volcanic eruptions can create new islands. When underwater volcanoes erupt, they can build enough material to break the surface and form new land. In 1963, an eruption off the coast of Iceland created the island of Surtsey, which grew to over a square kilometer in size. Scientists watched as life colonized the barren rock, seeds arriving on wind and waves, birds nesting, plants taking root. Within decades, Surtsey transformed from lifeless lava to a functioning ecosystem. It's a reminder that Earth is still creating new land, and that life is always ready to move in, to adapt, to claim even the newest ground. Earth's crust floats on the mantle. The solid crust we live on actually floats on the semi-liquid mantle beneath it, a concept called isostasy. Thicker, heavier crust sinks deeper into the mantle, while lighter crust floats higher. This is why mountains have deep roots extending into the mantle, balancing their height above the surface. When glaciers form and press down on the land, the crust sinks slightly. When the ice melts, the land slowly rebounds, rising over thousands of years. Scandinavia is still rising today, recovering from the weight of ice sheets that melted 10,000 years ago. The Earth is flexible, responsive, and always seeking balance. Time threes. Some mountains are growing, others shrinking. The Himalayas continue to rise as the Indian plate pushes into Asia, gaining a few millimeters each year. But erosion is always at work, wearing mountains down through rain, wind, ice, and gravity. In some ranges, erosion outpaces uplift, and the mountains slowly shrink. The Appalachian Mountains, once as tall as the Himalayas, have been worn down over hundreds of millions of years. Mountains are not eternal. They rise from the clash of continents and fall grain by grain, washed to the sea. The landscape is always changing, building and eroding in a slow dance between uplift and decay. Ocean water is constantly circulating. The ocean's water doesn't stay still. A vast interconnected system of currents, called the global conveyor belt, circulates water around the entire planet. Warm surface water flows toward the poles, where it cools, becomes denser, and sinks. This deep, cold water then flows toward the equator, eventually rising and warming again. The entire cycle can take 1,000 years or more. This circulation distributes heat, nutrients, and oxygen around the globe, influencing climate and supporting marine life. The ocean breathes in slow motion, a planetary scale rhythm that shapes weather and life across all the continents. Earth experiences about 50,000 earthquakes a year. Most are so small we never feel them, detected only by seismographs scattered around the world. But every day, the planet shifts, adjusts, and releases tension built up in its crust. The vast majority of these quakes occur along tectonic plate boundaries, where the Earth's surface is most active. Occasionally, the release is catastrophic, toppling cities and reshaping coastlines. But mostly, the Earth trembles quietly, a constant background hum of geological motion. We live on a restless planet, and the ground beneath us is never truly still. Rivers can reverse their flow. Under certain conditions, rivers can flow backward. The Chicago River was famously reversed by engineers in 1900 to prevent pollution from entering Lake Michigan. But natural reversals happen too. During major floods or when ocean tides push inland with enough force, rivers can temporarily reverse course. The Tonle Sap River in Cambodia reverses direction seasonally, flowing backward for half the year as monsoon rains swell the Mekong River. These reversals are reminders that rivers are not fixed. They respond to the forces around them, bending, shifting, and sometimes even turning around entirely. The oldest water on Earth is 2 billion years old. Deep beneath Canada, in a mine 3 kilometers underground, scientists discovered pockets of water that have been isolated for more than 2 billion years. This ancient water contains dissolved gases and minerals from a time when Earth's surface was very different. Studying it provides clues about early life and the conditions that existed when complex cells first evolved. The water tastes extremely salty, almost like seawater, and contains traces of hydrogen that microbes could potentially use for energy. It's a window into the deep past, trapped in stone, waiting billions of years to be found. Earth's axis wobbles. Earth's rotational axis doesn't point in exactly the same direction all the time. It wobbles slightly due to gravitational forces from the sun and moon, as well as the redistribution of mass on Earth's surface. This wobble called precession, traces a slow circle in the sky, taking about 26,000 years to complete. Thousands of years ago, the North Star was a different star. Thousands of years from now, it will be different again. The wobble also shifts which hemisphere receives more sunlight during summer, contributing to long-term climate cycles. Even Earth's spin is not perfectly steady. Fungi are Earth's greatest decomposers. When plants and animals die, fungi break them down, returning nutrients to the soil. Without fungi, dead organic matter would pile up, locking away essential elements like nitrogen and carbon. Fungi form vast underground networks of thread-like structures called mycelium, sometimes spanning kilometers. These networks connect trees, allowing them to share nutrients and even send chemical signals to each other. Fungi are not just mushrooms sprouting in the forest. They're the hidden recyclers, the connectors, the thread that ties the ecosystem together. They work in silence, in darkness, breaking down the dead to feed the living. Lightning creates glass. When lightning strikes sandy soil, the intense heat can melt the sand, fusing it into glassy tubes called fulgurites. These natural sculptures can be hollow or branching, following the path the lightning took through the ground. Some are centimeters long, others extend for meters. Fulgurites are fragile and rare, but they're proof of the incredible energy in a lightning strike. For a brief instant, the ground becomes so hot it turns to glass, preserving the lightning's path in a frozen moment of molten transformation. The ocean floor is younger than the continents, while the oldest continental rocks are over 4 billion years old. The oldest oceanic crust is only about 200 million years old. This is because oceanic crust is constantly being created at mid-ocean ridges and destroyed at subduction zones. The seafloor is recycled through the mantle, melted down, and reformed. Continental crust, being lighter and thicker, isn't subducted. It stays at the surface, accumulating, colliding, and building up over billions of years. The continents are ancient archives. The ocean floor is new, constantly remaking itself in the planet's slow churn. Snow can be pink in high mountain regions and polar areas. Snow sometimes takes on a pink or reddish hue. This happens because of algae that live in the snow and ice. These hardy organisms, called snow algae, contain pigments that protect them from UV radiation, giving the snow its color. As the algae multiply during warm periods, the pink spreads across snowfields. Interestingly, the darker color absorbs more sunlight, accelerating melting. Pink snow is beautiful, but it's also a sign of changing conditions, of life adapting to extreme environments, and of the subtle ways organisms shape even the coldest corners of the planet. Earth's deepest cave goes down 2,200 meters. Veriovkina Cave in the country of Georgia is the deepest known cave on Earth, plunging more than 2,200 meters below the surface. Exploring it requires rappelling down sheer drops, squeezing through tight passages, and navigating underground rivers. The descent takes days. At the bottom, the air is warm and humid, far removed from the surface world. Caves like this form over millions of years as water dissolves limestone, carving vast chambers and tunnels. They're hidden worlds beneath our feet, mapped only recently, and still largely unexplored. The Earth holds depths we're only beginning to fathom. Tides affect the Earth's crust, not just the ocean. While we notice tides in the ocean, the moon's gravity also pulls on the solid Earth itself. The planet bulges slightly, rising and falling by as much as 30 centimeters twice a day. This earth tide is too subtle to feel, but sensitive instruments can measure it. It affects everything from GPS accuracy to the timing of earthquakes. Even stone and metal respond to the moon's pull, bending and flexing in a rhythm as old as the Earth-Moon system. The planet is not rigid. It breathes with the tides, yielding to invisible forces from space. Clouds can weigh millions of tons. A typical cumulus cloud, the kind you see on a sunny day, contains about 500,000 kilograms of water. Larger storm clouds can hold millions of tons. Yet they float because the water is dispersed as tiny droplets, suspended by updrafts of warm air. The droplets are so small that air resistance keeps them aloft. When they grow large enough, they fall as rain. Clouds are not weightless. They're vast reservoirs of water hanging in the sky, held up by air currents, waiting for the moment when gravity finally pulls them down. And with that, we've journeyed across 100 facts about Earth, from the fire at its core to the ice and its poles, from the depths of the ocean to the edges of the atmosphere, from ancient rocks to living forest. I hope these facts have carried you gently into rest. May your dreams be as vast as the oceans, as quiet as the deep earth, and as peaceful as the turning of the world beneath the stars. Good night,